Continue with the last presentation today. It will be given by Natalia Slawinska. She is PhD student at the Faculty of Biology and Environmental Protection of the University in Lodz. And for our German association members, Natalia and Bartosz will also hold presentations in our annual meeting end of the year. And Natalia, the floor is yours, please.
Hello, everyone. Okay, can you see my presentation?
Yes.
Yes, we can.
Okay. All right.
Now much better.
Yeah. I would like to tell you about my research, which is on the effect of thermal processing on antioxidant and anticoagulant activity of seed buckthorn seeds. Okay, I think I can skip this short introduction of seed buckthorn. This was covered previously. So now, the most often studied parts of seed buckthorn from the medical perspective are...
Sorry, Natalia, I cannot see your screen, only a gray one.
Oh.
I can see, Axel.
You can see it, yes.
Okay, so and only my problem. Okay, sorry.
Okay. So the most studied parts of seed buckthorn are pulp oil, fruits, and seed oil, and a little bit less is known about the bark, the seeds, and leaves and twigs. And I chose to study seed buckthorn seeds specifically because, as I said before, many studies are focusing only on the seed oil. And there's just not enough information about the activity, biological activity, and the content of the seeds. And as seeds are often a byproduct of the food industry, for example, in juice production or jam production, I think that they could be used as food additives, nutraceuticals, or just for extraction of active substances. And what do we know so far about the activity of seed buckthorn seeds? We already know that they have antioxidant activity and some beneficial effects on the cardiovascular system. For example, anti-hyperlipidemic activity. They can decrease the amount of cholesterol. They are antihypertensive, hypoglycemic, and have anti-cancer, cytoprotective, retinoprotective, anti-melanogenesis, and antibacterial properties as well. Some of these activities were studied in vivo, which is in orange text. But the things that we do not know about the seed buckthorn seeds are their effect on blood coagulation and the effect of thermal processing on their antioxidant activity. And this brings us to my research objective, which is the assessment of antioxidant activity of seed buckthorn seeds, the hemostasis modulating activity of seed buckthorn seeds, and the effect of high temperature on these two activities. This is depicted in this graph. I studied two types of extract from the seeds, the regular extract, which was not thermally processed, and the extract from roasted seeds, and performed several assays to check their activity in relation to oxidative stress and hemostasis. Now, why did I choose to study the effect of thermal processing on the seeds? Well, I think it's pretty obvious that Seeds, generally seeds, as a component of food, are often subjected to high temperatures. For example, in bread baking process, and this can alter their chemical content and biological activity. For example, thermal processing can decrease the concentration of active compounds in the seeds. It can alter the chemical structure of compounds, increase lipid content, or change the lipid profile. But it can also increase the strength of a particular biological activity. For example, heating Nigella sativa seeds enhance the anti-proliferative activity. And I chose to study the anticoagulant activity of the seeds because, as was previously mentioned by Bartosz, my colleague, cardiovascular diseases are the leading cause of death worldwide, and we still need new anticoagulant or antiplatelet drugs that are crucial in treatment of these diseases. For example, in ischemic heart disease, because drugs that are used at the moment can cause some adverse effects, and scientists are still searching for new compounds that would have fewer side effects and similar activity. Now, I'll move on to the experimental part of my research. The research was conducted with the Institute of Soil Science and Plant Cultivation at the Department of Biochemistry and Crop Quality in Puławy. And sea buckthorn seeds were obtained from a horticultural farm in Sokółka. As previously mentioned, the plant material included extract from regular, which are not roasted, sea buckthorn seeds, and extract from roasted sea buckthorn seeds. Now, this is the method of extraction which we used. First, seeds were separated from pulp and skin. Then a portion of the seeds was roasted, first at 280 degrees Celsius for 10 minutes, and then for 175 degrees Celsius, which was similar to the process of bread baking. Next, the seeds were dried and milled, then defatted with hexane. The organic solvents were removed by rotary evaporation, and then they were extracted with methanol, defatted again, extracted with butanol, rotary evaporated, and dissolved in tert-butanol. After that, they were freeze-dried and stored for further use. The human biological material included human plasma and human whole blood, which was collected on 3.2 sodium citrate. The blood samples were collected at the Diagnostica blood collection point in Łódź from healthy non-smoking volunteers, and the experiments were conducted with the consent of Bioethics Committee of the University of Łódź. Now, the antioxidant activity assays that I used included the measurement of the levels of oxidative stress markers that are thiobarbituric acid reactive substances, carbonyl groups, and level of fuel groups. The biological material used in these assays was human plasma. And I used a model with an oxidative stress inducer, which was hydrogen dioxide and ion, which leads to a formation of hydroxyl radical. That is a potent inducer of oxidative stress. For the hemostasis assay, I used a machine called TITAS, which stands for Total Thrombus Formation Analysis System. It uses a microchip flow chamber, which is depicted here. There's a special chamber that is covered with tissue thromboplastin and collagen, which imitates the conditions in a damaged blood vessel. The machine records changes in flow pressure, which can allow us to track the formation of thrombus. And in this case, the biological material was human whole blood. And this method allows us to check the effects on primary hemostasis and secondary hemostasis, which focuses only on the extrinsic pathway. Now the results. First, I'll show you the results from our study of the chemical content of both of the extracts. For now, we have only the flavonoid content. And here in red, I've marked the substances that had the highest concentrations in both of the extracts. As you can see, there was, in most cases, there was some loss of flavonoid content in the extract from roasted seeds, but it wasn't that drastic, especially in comparison to the research of Ursache et al., who studied the effect of thermal processing on the extract for seed back from berries. In that case, the loss of photochemicals was as high as 77 to 90%. And in the seeds, the total flavonoid loss was only 28%. In one case, the content in the extract from roasted seeds was higher, which is marked in blue. Now, the effect of the extracts on lipid peroxidation in human plasma, measured by the concentration of tuberbutyric acid-reactive substances. As you can see, both of the extracts had antioxidant activity. In the case of the extracts from regular seeds, only 3 concentrations, 5, 10, and 50 micrograms per milliliter, had significant effects. The highest concentration inhibited lipid peroxidation by approximately 53%. And in the case of the extract from roasted seeds, all of the concentrations had a significant effect. The percent of inhibition was slightly lower here, but there is no significant differences between the activity of these 2 extracts. So roasting did not significantly impact the antioxidant activity of the seeds. Here are the results from the measurement of protein carbonylation. And here all except 1 concentration had the effect in the extract from regular seeds, and in the case of extract from roasted seeds, all of the concentration had an antioxidant effect. The effect was not dependent on the dose, so all of the concentrations had similar effects, and the differences between both extracts were not significant as well. But that was not the case in the effect of the extracts on the levels of thiol groups. The extract from regular seeds did not significantly affect the level of thiol groups. But the extract from roasted seeds did, and did this at the two lowest concentrations, 0.5 and 1 micrograms per milliliter. This is an interesting result, and for now we don't really know which chemicals, which compounds are responsible from this gain of function. We think that some more research on the content of the both extracts can help us with this. Now I will move on to the effect of the seed bag from seeds on coagulation. These are the results from the TITAS assay, and as you can see, only one concentration of the extract from roasted seeds had an effect, and it decreased coagulation, which means that it prolonged the time of formation of thrombi. This is depicted in this graph. Here in blue is the control, and as you can see, the two smaller concentrations slightly prolonged the thrombus formation, but these results were not statistically significant. But the highest concentration of 50 micrograms per milliliter had statistically significant effect. So we can see that seed bag from seeds do have some anticoagulant compounds, which is an interesting thing that we plan to further research. So now the conclusions. Extracts from regular and roasted seed bag from seeds inhibited lipid peroxidation and protein carbonylation induced by an oxidative stress inducer. The antioxidant activity was not negatively impacted by thermal processing, and this was probably because the flavonoid loss was comparatively small in comparison to other research. And thiol group's oxidation was prevented only by the extract from roasted seeds. As for the anticoagulant activity, only the extract from roasted seeds at the highest concentration had anticoagulant effect. And the mechanism behind the prevention of thiol groups oxidation and anticoagulant activity in the roasted extract are unknown yet. It's possible that this is caused by other phytochemicals, not only flavonoids. We plan to measure the effects of individual compounds that will isolate from the extracts. So this might prove to be this might provide us with better insights on this topic. Yes, so we think that seed bag from seeds might have the potential to be used as functional food in regards to the activity, but further in vivo testing would be needed to ascertain if these effects are also applicable in organism, not only in vitro. And we think that isolation and study of individual compounds from seed-background seeds may lead to the discovery of some new anticoagulant agents, which is the topic of our further studies. But for now, we will see. Thank you. This is all.
Thank you very much, Natalia, for this excellent, clear presentation. I would give the word to the audience if there's any questions to you. Thorsten? Please.
Thank you, Natalia, for a nice presentation. My question is, do you know which varieties you used for your investigation? Was it German varieties or Russian varieties? Do you know it?
Actually, I'm not too sure because in our research group, Professor Anna Stockmal was responsible for the cultivation and collection of sea buckthorn. I don't really know too much about these aspects, and I only focus on the biochemical studies. So unfortunately, I don't really know. But I will ask her.
Okay, thank you.
It seems like good information to have.
Okay. Thanks, Thorsten. Anybody else? A question? Dr. Ahani, please.
And thank you for your great paper. I would like to know something not by.
I'm sorry, I can't really hear you. The connection is.
I cannot understand you because maybe the internet connection is not
Yeah.
well. Maybe you can write in the chat if you like.
Yeah.
May I speak? Oh,
Difficult to understand you.
unfortunately, the connection is poor, and I don't understand about the comparing between roasted seeds and regular seeds. Which of them in all was better?
Sorry, I didn't catch that.
Please repeat your question.
There's no connection. I propose that Virendra Singh, who raised his hand, is the next.
Yes, my question is, linseed has been used in bread making. Whether the same way sea buckthorn seeds, roasted seeds are being used in any country, it is a common practice or not. Second question is, how much quantity of sea buckthorn roasted seeds can safely used?
We do not know yet about the safety of the seeds. I plan to do some cytotoxicity and genotoxicity studies, but further in vivo studies will be needed to fully ascertain that. And as for the bread making, I saw some research on the quality of bread that used sea buckthorn flour. But I personally do not know about any products that you can buy that contain the seeds already. At least I didn't really encounter it yet.
Okay, thanks for your answer. Thomas, do you have something in the chat?
I asked Stanislav Pluta if you know about the varieties around Białystok that are grown there, but he wrote that you also need to contact someone to know about.
Okay.
So, other question? Not? Yes, I think no question.